Hey, good afternoon. Good afternoon, Alicia. Good afternoon, everyone. Um, all right, so okay. I see three people. uh, it's 201, and yeah, just it's not that bad. I mean, to um, to look at it from positive perspective, right? Hello, how are you, Claudia?
Hello, Professor.
How are you? Good afternoon. So I see four people now, and don't forget to um, you know what I'm trying to say. Don't forget to sign into the discussion board. Okay, today. So I see um, five people. So I have pretty much the same number of people. I have. Okay. So uh, so we need to pick up from. I hope of course, everyone. Uh, everyone did well in the quiz too. So actually, what we are doing today is um, actually related to quiz two. As I said, ideally we should have covered um, this part before quiz two, but that's not possible. Logistically, logistically, that's not possible. And as this, that's why I've been telling you that the main lecture, we go by the main lecture, and in the by the main lecture, we have already covered this. And the collaborate session is only the review and reflection of the main lecture. So ideally, um, you should have already um, studied uh, this topic by the main lecture. And by the way, by the main lecture, you should be we are already into this. Not just this, also, I believe this is done. I mean, look, all of these, all of these videos are already grayed out. That means, it's been already done. Um, and of course, we had to use, we couldn't even waste the spring break. During the spring break, it was already, you were already informed, even during the spring break. Um, the main lecture videos will be assigned, released and assigned, per schedule. Um, so you should have got these. Uh, you should have already studied these already, and we are already into risk and return part two, right? Those videos are, yeah, they are already active, right? So that's the reality, right? That's the how time constrained we are, and we have to really work diligently um, to be on par with the or to be up on par, or what should I say, with uh, the progress of the class. All right, so uh, let me go back to this file. Okay, in our last class, we downloaded this file. We downloaded this data from Yahoo Finance, which is Apple monthly data for the last 5 years. And if you and so that means you need to open this file, okay, that you uh, that you downloaded last time. And also, if you were not, if you were not, if you were not there last Thursday, if you were absent last Thursday, uh, I went extra mile to, post that. file for you in the on the blackboard, right? So if you go to topic 5, right, you will see this one, Apple 22 spring, 22 spring. This is the file, my file, right, that I downloaded last night. So you can download this. But you know, it should be really you to do. So here, so we sorted the data in descending order, right? When I say descending order or ascending order, you should already understand what that means. We don't have time to repeat the same thing and explain the same thing all over again every time. Descending order means like this. You should be okay from the latest to the oldest, right? And I also told you this is the end of the month data. And when we downloaded it, so you might wonder, why is the date April 1st, March 1st? I mean, that's not the end of the month. So are these beginning of the month date? No, I told you, it's just the way, it's end of the month. It's just the way the dates are shown. It's just the way the month is represented. 4/1/2022 doesn't mean first day of April. It's just the way it is to represent April. So these are just months, okay? And these are end of the month, closing, adjusted closing price, adjusted close, right? So if you have those questions, I believe this must have answered your your question. Now the next, also when we downloaded this data, that was when we downloaded last Thursday. Last Thursday was April 28th. So it's not exactly the close price of the month, because the last transaction was on the 29th, right? The last transaction of the month was on the 29th. But when we because we downloaded on the 28th, the data as of the 28th, right? At the end of the trading of the day, at the closing, right? That was the closest to the end of the month we could get. So think about it. Today is May 2nd, but if I download the data today, May data is as of today, right? As of the end of May data will not be really May 31st, right? End of today, because we haven't reached May 31st, right? We haven't reached May 31st, but as of today, May 2nd, right? Today's close price will be today's data, right? I mean, representing May. So you have to keep that in mind, okay? So actual end of April data may be slightly different from this, but that doesn't really matter. We are, so next. So these are, price at time t, and So how do we find return? We need to find return. Return is basically, I already wrote down here, PT minus 1 over PT minus 1. And I told you we don't have to bother with dividend because we are dealing with monthly data. We don't have dividend every month, right? Dividend is paid only, if ever it is paid, it's paid only, once a quarter, right? So that's why we are using adjusted close price, because adjusted close price is adjusted for what's going on? Why can't I write on this ink? And I don't have ink. I should have ink. Okay, something's okay. It looks like I don't have. I can't draw on this. But anyway, so it's adjusted for stock splits and dividends. So we can just ignore dividend, now, then how do we? So we need PT minus 1, and we know what PT minus 1 is because think about it. PT, if this is PT, if this is PT, PT minus 1 for April is actually, then it is PT minus 1 should be March price, isn't it right? From April, right? If you look at it from April, if you look at this data from April, if April is PT, March price is PT minus 1, right? You get it? So then, all you need to do here is, okay, then this is PT minus 1, PT, and then this is PT minus 1. All right, then you divide it by PT minus 1. Okay, of course it will be a negative number, almost, and we give it percentage, right? And then don't leave it like that because it's rounded. If you leave it as integer, it's rounded too much, it's inevitably rounded. So increase decimal. Use at least 2 to 3 decimal places. 2 to 3 decimal places, right? And then once you are done with that, all you need to do is just drag it down. And we have, now we have the monthly returns. These are actual monthly returns, right? These are actual monthly returns. At this point, you don't go all the way down here because obviously to do this, you need the data from the previous month, and we don't have data. We don't have April 2017. So if you drag it down, it's not going to calculate anything. It cannot be calculated, right? But we need to make sure we have 60 data points because 5 years is 60 months, right? 5 years is 60 months. So let's, if I hide, it's 59. So, I should have got, okay. So let me add, that's why we should have, started from April of, we started from April of 2017. Somehow the data was, April. That's 2022. See, it started from May of 2017. So all I need to do is, it's okay. I can use 59 data points. I'm gonna, but I can quickly go to Yahoo Finance. Let's see, and go to Apple again. Oh, today, every day it's been like this. At the beginning, the market was, trying to regain, and then by the by afternoon, uh, it's pairing all its gains, earlier gains, so uh, uh, very disappointing again. But let me get Apple. Historical data, and start date 2017. Yeah, too much. What's going on? It's not. I'll have to manually do this. All right. April, right? What's going on? Okay. And then monthly, apply, and let me get 2000. So adjusted close, just the adjusted close. Okay. Ah. Ah. Okay, so I'll just okay, and then what is this? Not oh. Oh, okay. Never mind. I'll have to redo this because this. Why is it doing this? Uh, it's not even 2017, but I'm gonna fix that later. But Given this, you want to know what is the average monthly return. We want to find the average monthly return. So yeah, we can take the average, which is simply using the average command, right? You highlight all of these data points and enter. So this is average monthly return, and you might say, oh, that's not that impressive. It was just 2.9%, 2.89. I mean, what's the big deal? That doesn't seem very impressive. No, but think about it. That is actually impressive. Why? Think about it. If the monthly growth, this is monthly return, which is also monthly growth rate. Return is the same thing as growth rate in scenario one, right? Remember? And then think about it. If this is the monthly return over 5 years, that's like 60 months, right? What is the growth over 5 years? You know very well. It is, if monthly is like this, and then we raise it to 60 months, or even 59, okay? And then -1, because it's the what you get is gross. If you do it like this, then that's including what is already there. In other words, that's gross return. So you must subtract 1 to get the net return. Now the net return alone is 452%. 452%, right? That means over 5 years, 452% growth, right? So, and then just think about it. From this is the May 2017, it was $36. 2017, $36. Now it's $156. That's almost 5 times, exactly 5-fold, right? 5-fold growth. 5-fold growth is 400% growth, net growth, isn't that right? Think about it, from if anything grew from 3 to 15, yeah, 15 is 5 times 3, but the net growth is 4 times, isn't that right? So this is exactly a formidable growth. I mean, over 5 years, almost 400% net growth, right? So 2% a month, 2.9% a month is not an unimpressive growth. It's an impressive growth. Also, some of you might wonder, was Apple that low back in 2017? $36? No. Actually, the price Apple was, I told you before, in 2014 there was a split, like 7-to-1 split, and before the split, the price was almost $660. That's 2014. Or if I remember correctly, 2014 or 2016. But after split, I've been telling you, after split, the prices need to be prorated. The price need to be adjusted. The pre-split prices must be adjusted to be in line with the post-split price. So all of these is the result of adjusting for splits, right? And I told you, even 2020, August 2020. I mean, in the even in the recent history, most recent history, right? Last 5 years, right? There was a split here, 7-1 split. Yeah, I told you, 2014 there was a 7-1 split, and then even recently, right, 2020 August, 4-1 split, right? I bought more Apple, at the time. So that's why, we need the next thing. Next thing you want to know is you would like to see, okay, I'm gonna first copy this and paste here, but I will paste only values, right? I will select paste special and paste values, only the values, so that this won't be, a formula here. Okay, why did I do that? So that I can sort this in descending order, right? Sort this from the largest to the smallest, so that I would know when was the best month for Apple, when was the best time, and when was the worst time, right? So if I do that, and if you do that, did you guys do this? Mm-hmm. I don't know, you're awfully quiet, so I have 9 people. Some people left. This is sad. So the best month was August 2020. The monthly growth was 21%. Okay. And the worst month was November 2018. They lost 18%, right? 18%. So at some, okay, this one. Now you can't do it. You can't do that sorting when we have formula in the cell, because when the you think it will sort like this, no, it won't, because when the order of the data set changes, it won't still be the same thing. So to sort it, we'll have to we'll have to we'll have to have it only as numerical data, not formula, right? But coming back to this, so we know the average was. I'm going to move this somewhere else, far away. Average monthly return is 2.89. Question is, so how far, or on average, you want to know how far is the again, if I sort this in descending order, um, you want to know how far each data point is from the average, right? How far they are away from the average, right? So because this 21% return is almost 19% above average, but 3.27% is just about not that much difference, just about 4% difference. I mean 0.4% difference. So each data point is either far away or not that far away from the mean, right? And if we have an idea of how far away each data point is from the mean on average, right? On average, how far it is, we can have a pretty good guess of what would be the range of variation, right? What would be the range of variation? Uh, Average range of variation, right? So to do that, yeah, we're going to be, it's basically the difference, right? Or the deviation. So I'm going to call it deviation, or, but, deviation is basically difference. But it's simple. I'm going to take the difference between the monthly data, monthly return, and the average. Okay, and then here I'm gonna hit F4 and lock the mean, because I'm going to just drag it down. And when you drag it down, you don't want this C62 to change. You don't want you want it to be fixed and locked into C62. So that's why you lock it, because the mean shouldn't change, right? But if you, without locking it, if you drag it down, it will go down. It will also go down, right? This will, so, but after locking it, now let's drag it down. So I'm going to drag it down all the way. Okay. So these are basically deviations, or the difference term, difference, or the deviations, right? Deviation from the mean. And since we wanted to find the average deviation, you would like to know, okay, if I take the average, that should give me, that should give me the average difference, average deviation. But if you do that, you'll be surprised. It will come to zero. Of course, it will have to come to zero. Why? Think about it. The mean is a very neutral number. I mean, we got this mean because by summing everything and dividing it by n, right, by the number of data points. But then if you do that, if you take the difference, all those difference terms are, some of them are positive, some of them are negative, and so think about it. It may not be exactly the case, but pretty much half of them would be positive, half of them would be negative. And this negative half and positive half will cancel out each other. Then obviously, then if you divide it by n, it will just be 0. So that's why we cannot use the difference terms, right, to find the average of that. Instead, then what do? Let's square the difference terms. If we square the difference terms, Think about it. Any number squared is always positive, right? There's nothing that can be negative when squared in real numbers, right? And then we can, some of you may say, why can't we just, use the positive, difference terms? Again, if you use only positive difference terms, then that means you are throwing away half the data set, right? And if you throw away half the data set and use only the other half, then it's not doing the it's not a correct picture. I mean, it's not doing the correct job, right? Because over 5 years, we must have 60 data points, and 60 data points will show the dynamics in the data, right? The dynamics. So, in other words, how the returns data changed, how it has moved, right? So obviously you can't throw away, half of it. So if the only way we can preserve all those, 60 data points is, by using the square root, and then if we, by squaring it. If you square it, then everything is positive, right? So we'll square this, square it, and then of course give it percentage, give it 3 decimal places, and then we drag it down. Now then we can sum this. We can sum this and divide it by number of observations, number of data points, to find average. Okay, but then here's a problem. We can sum everything there, right? Sum everything there. Nothing is in E61, so I'll just sum. Oh, again. Okay, and go up to E60, and there'll be 59 data points. And this is called sum of squares. Sum of squares, right? That's the term. Literally, it means sum of the squared sum of the squared terms, right? Sum of squares. I'm going to use something light. Okay, sum of squares. And then you might want to divide it by n. No, you cannot divide it by n, but you'll have to divide it by n minus 1. Okay, it's called degree of freedom, loss of 1 degree of freedom. When you have a sample data set, sample means, it's a subset of the data, subset. It's a local data. What that means, think about it. Apple, this is not the entire data set we can get from Apple. Isn't that right? Because Apple has been around for 40 years. So the totality of the data must start from 1981, right? That's 41 years worth of data. And that's called, so that's the whole, entirety. And that's called population, right? but this is only a most recent 5 years. This is the data from the most recent 5 years, right? So it's a local data set. Any local data set is called sample, okay? Sample. Yeah, we sampled 5 years, most recent 5 years from the entire 41-year data set, data from Apple, right? So it's sample. Now, if you are using the entire population, then you can divide it by n. But if you are using a sample data set, then you cannot divide it by n. You'll have to divide it by n minus 1 because there's a loss of 1 degree of freedom. Okay, so then we're going to divide this by n minus 1. And we know n is, in this case, we have only 59 data set, 59 data points, but just to make sure, I'm going to use count command so that this will count the number of that way, the number of data points. That way, nothing is left to chance, or there's no loophole, or loose end. There's no loose end. By doing it this way, we're gonna, and then we subtract 1 from it. Subtract 1 from it, and of course, that means we have to put everything in the denominator. We have to put the denominator, everything in the denominator, in the parentheses. Otherwise, you all know PEMDAS, right? What happens is, this division will happen first, right? And from that, it will subtract 1. Now, then that's going to be completely wrong. You subtract 1 from the denominator, so it has to be in the parentheses, right? And then if you do that, we get a number like that, which is called variance. Okay? So basically, variance is the average deviation from the mean, average deviation of each data point from the mean. Okay? But this is not a life-size picture. This is not the life-size picture. Why? Because this is a blown-up picture. Why? Because remember we squared the difference terms, right? We squared the difference terms. So when you squared the difference terms, so this is not the life-size picture, but a blown-up picture, right? But we know how to convert. We know how to revert this back to life-size picture, right? Isn't that right? Yes, we do, because we got to this by squaring the difference terms. So if we take the square root of this number, then that will be the life-size picture. Now I'm just copying the cell below just to keep consistently using the same font. Okay, it's for the font formatting. So you have to delete, what was being copied there. So again, we'll have to take the square root, and the square root is SQRT, or you can raise it to half power, square root of this, right? Now that is the life-size picture of the average deviation from the mean, right? The average deviation of each data point from the mean. So that way, it's called, standard deviation, STDV. So the standard deviation is the square root of variance. Variance is the square term of standard deviation. And then, how does this how does this help us? How is it Okay, so here's the thing. Okay, so we want to tap into the properties of distribution. So in normal, that means in our example, right? Oh, no, 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 not radar. What?
13.
Okay, not that. Voice options, no. Draw. Okay. So it means our mean expected return is the mean return, which is 2.89%. That's the mean, and one standard deviation is like 8 point. What was our standard deviation? 8.7%, right? It's actually not there, but what it means is this is 8.7%. One standard deviation is 8.7%. Also 8.7%. So one standard deviation above mean will be like 10 point, so it will be like 11.59. We'll just 11 point, let's say 11.6%. And one standard deviation below mean would be negative, whatever, it will be negative, almost, negative 5.9%, right? $2.89. If okay. Yeah, 5.8 or 5.9%. So and then two standard deviation. So basically the properties, if we rely on the uh, if you understand, if you have taken statistics, or I mean even studied my main lecture videos, you would understand what I'm trying to say. Now the mean between so this is 2.8, right? 2 point, almost 2.9%. 2.89, so 2.9, and this is one standard deviation above mean is whatever the probability of getting any return between any probability of getting any return between negative 5.9 and 11.6% is 68%. There is a 68% probability of being within one standard deviation around the mean. Okay, and then two standard deviation would If you go another 8.7 above it, it will be 19. So it will be 20.3, right? And then this minus again 8.7, 5.9 minus 5.7, negative 14.6%. And the probability of getting anything between negative 14.6 and positive 20.3, that probability is 96%, right? From here to here, it's 96%. Okay? That means, the probability of getting something between the mean and the, one standard deviation above the mean, that's half of this 68%. So that probability is 34%. And here also this probability, this area is 34% as well. Now, one standard deviation around the mean is 68%. Two standard deviations around the mean, the probability of that is 96%. So what's the difference between the two? The difference between the two is 28%. That half of that 28% lies here, and half of that 28% lies here, which is, half of that is 14, half of that is 14, right? So that means you have 14% probability of getting any return between 11.6 and 20.3. And also you have, 14% probability of getting any return between negative 5.9% and negative 14%, 14.6%. And then outside 94%, there's only 4% left. Out of that 4%, 2% is lying above, right?
Professor, is this almost
yeah.
like the bell curve?
Yeah, this is the bell curve. Yes, of course. That looks like the bell curve. That looks like the bell. So it's the bell curve. So this probability is 2%, and here it's also 2%, right? So now we can associate. In other words, we can tell with probability what kind of return we can get. That's one thing we can. That's one thing we can take away from the mean and the standard deviation and the normal distribution. And another thing, we're out of time, but from mean and standard deviation, we can also set a criteria for selecting the assets, right? So that we are out of time already. So we'll talk about that on Thursday. Okay. All righty. So if you have any questions, I can. Tia, you have a question?
No, that
okay.
was just my hand up with the bell curve because it looked familiar from my statistics class.
Yeah. But you need to put that into a context, because what you do in the statistics class is just statistics for its own sake, but not put into a context. You need to contextualize.
Finance.
All right. Yeah.
Thank you.
All righty. So I will see you guys on Thursday. If you have any questions, please email me. I have another class starting in 5 minutes, so I have to run to that. All right. Take care, everyone.
Have a good day, Professor.
You too. All right. So stop recording.